This is a study island video on the topic solving equations using tables. So this is another method that's not quite an algebraic method, not usually the most efficient, but it's a way of thinking that you should kind of understand. So you're going to do these problems. It's very simple. You have two functions. What you're going to do is you're going to set up a table with a list of input values, and you're going to evaluate each function for each of those values until you get one input value where each function has an identical output. Now, all that sounds a little bit more complicated than it is, so let's just get into it. The first thing is we're going to establish a column in the table for x. That's our input value. The next column is going to be one of our functions. We'll say f of x, which in this case is 4 to the power of x plus 2 minus 3. Our other function is g of x, which in this case is simply negative 4 times x minus 10. So we have three columns, input value, and then one column for each function. Now, we're going to go ahead and put in some values. Now we can put in anything we want, but let's be smart about this. We have a multiple choice questionnaire here. It makes things a lot more quick if you use the choices that are available to you in order to eliminate your options. So I like to go from smallest to largest. So let's just start with negative 10. If x is negative 10, then what is f of negative 10? It is 4 to the power of negative 10 plus 2, and then minus 3. Okay, well, that makes f of negative 10 is equal to 4 to the power of negative 8 minus 3. Now, if you've never seen a negative exponent before, or if you don't remember seeing them, now is a good time to kind of step aside and review what negative exponents are. If you already know what a negative exponent is, if you know exactly how to write 4 to the negative 8 power already, skip ahead a couple minutes until you see this little chart back on there, because I'm going to take this away for a moment and explain how to calculate a negative exponent. Here's how you calculate a negative exponent. Here's what a negative exponent is. To figure this out, let's start with a regular exponent, a positive exponent. Let's just say we had 3 to the 5th power. What is 3 to the 5th power if I write it out? It is 3 times 3 times 3 times 3 times 3. Now, to better explain this, I'm actually going to think of 3 to the 5th power as 1 times 3 times 3 times 3 times 3 times 3. If I am multiplying something by 1, I don't change it. So nothing's changed there. So it's easy to imagine that if you have 3 to the 5th power, that you start with 1, and then you multiply by 3, which is what we call the base, 5 times. And 5 is the exponent. So 1 times 3 times 3 times 3 times 3 times 3. There's 5 3's. So what does this have to do with negative exponents? The one thing that you have to get through your head is that a negative exponent has nothing to do with a negative number, a negative outcome. That's not what it is. When you multiply things a lot, the numbers get really, really large. Positive exponents make the number bigger by multiplying. Negative exponents make the numbers smaller by dividing. So if I had the number 3 to the negative 5th power, what that is, instead of 1 times 3 times 3 times 3 times 3 times 3, it's going to be 1 divided by 3, divided by 3, divided by 3. And we're doing that 5 times. So that's what a negative exponent does. It makes division instead of multiplication. So 1 divided by 3, divided by 3, divided by 3, divided by 3, divided by 3. Now, we don't write it this way in algebra. We don't use these little division symbols. Whenever we do division, we use fractions. So let's rewrite this. What is 1 divided by 3? Well, it's 1/3. And if I want to divide something by 3, I can just multiply it by 1/3. So it's going to be 1/3 times 1/3 times 1/3 times 1/3 times 1/3. So a negative exponent, instead of doing 1 times 3 5 times, you're doing 1 divided by 3 5 times. And that's the exact same as saying 1/3 multiplied by itself 5 times. So another way that people write negative exponents is they simply write them as a fraction with a positive exponent, but in the denominator. So how could I write all of this? I could write it as 1 divided by 3 to the 5th power. These two things are equal to each other. Okay, so you can write 3 to the negative 5th power as 1 divided by 3 to the 5th power. So back to our other problem, we had 4 to the negative 8th power, which is simply 1 over 4 to the 8th power. So we're dividing by that whole number. So now we just calculate what 4 to the 8th power is, and we have our answer. So 4 to the 8th power, and you can feel free to use a calculator or the Google calculator on all this. We have 4, and then the caret that's above the 6 to the 8th power says 65,536. So let's go ahead and go back to our problem that we had. Okay, so we have 4 to the negative 8th power, which is 65,536 in the denominator, with 1 as the numerator. So we have f of negative 10 is equal to 1 over 65,536, and then minus 3. So we have a very, very, very small number here, because this is a little tiny bit, and then take away 3. So if this was 0 minus 3, we would be at negative 3. So this is going to be negative 2.99999. That's going to be a very small number. If you wanted to actually calculate it out to a decimal, you would simply do 4 to the power of negative 8 minus 3, and you have your answer. Don't be afraid to plug in all of these calculations that you're doing for each of these functions into your calculator. We are not testing whether or not you have an ability to work with all these fractions and stuff. We'll do that separately. If you just want to plug this stuff into your calculator, that's okay. So f of negative 10 is approximately negative 2.99998. Let's just call it that for now. All right, so what's g of x? G of x, in this case, g of negative 10, is equal to negative 4 times negative 10 minus 10. That is equal to positive 40 minus 10, and that is equal to 30. So the question is, did we get the same output? Clearly not. Negative 2.99998 is not the same as 30, so our answer is not negative 10. That's not the input we want. Let's test another input. Another input we can test. We know it's not C. Let's try the next lowest one, negative 2. So again, for f of x, we have f of negative 2 now, which is equal to 4 to the power of negative 2 plus 2 minus 3. That is equal to 4 to the power of 0 minus 3. Power of 0, what's anything to the power of 0? Anything to the power of 0 is simply 1. If we go back to our example that we did earlier, and we can see it down here, if 3 to the 5th power is equal to 1 times 3 times 3 times 3 times 3 times 3, well then 4 to the power of 0, we start with 1 like always, and we multiply by 4 exactly no times. So if we're not multiplying by 4 at all, we just are left with our 1. So that's the answer. It's just 1. And then 1 minus 3 is negative 2. So 4 to the power of 0 is simply just 1. And now we minus 3 and we get negative 2. Next, g of x, g of negative 2, is equal to negative 4 times negative 2 minus 10. That is equal to positive 8 minus 10, and that is equal to negative 2. We've got it. That's our answer, negative 2. Now, because all of these have only the one answer, we know we're done. But just because you put in a table and found one answer doesn't mean that is the only one. So in the future, you might have to continue your table to find more than one answer. But because of our multiple choice options, we know it's negative 2, and we can move on. We'll do another one. These are two linear equations. You should recognize these as having only one spot that they intersect. Let's go ahead and do these problems. Again, we'll set up a column for our input variable, which is x. We'll set up a column for our first function, f of x, being equal to 9x plus 27. And we'll set up a column for our g of x, which is equal to negative 9x minus 108. Okay, first input value, let's try whichever one you want. If you want to try -3 first, let's just try -3. F of -3 then is equal to 9 times -3 plus 27. 9 times -3 is -27. And so this is equal to -27 plus 27, which is 0. So when x was -3, f of x is 0. So f of -3 is 0. G of x, g of -3 now, is equal to -9 times 3, times -3 minus 108. -9 times -3 is positive 27. And 27 minus 108, it doesn't even matter what it is. It's not 0. It's not what we just had. This would end up being 81, -81, I should say. So clearly not the same value. So our input value is not -3. Next, -12, let's say. There's not a particular order you could try these in. You can do it whatever order you like, really. If you're just going through the answers, it's fairly simple. F of -12 is equal to 9 times 12 plus 27. 9 times 12 is 108, so we have 108 plus 27. And 108 plus 27 is 135. Again, feel free to simply plug all this stuff into a calculator. If right away, oh, you know what? I actually did this wrong. It's -12, isn't it? Times -12. This is -108 plus 27. That's very important. So -108 plus 27 is -81. But again, feel free to plug all this stuff into a calculator. So from right in the very beginning, if you said, okay, 9 times x plus 27 and x is -12, you could type in right away 9 times -12 and plus 27, and you get your answer, -81. And that actually makes it easy, because if you saw that, -81, you could go just delete the 12 and put in your -3 instead, and you get your 0 right away. And so we have 0, and we have our -81, and we can go ahead and fill this out for our other values too. I believe one of them was -81, and the other is -7.5. So if you wanted -81 and -7.5, you can fill those out right away. F of -81. We've already input the formula up here in Google. We just change our -3 to -81, and we get -702. And for -7.5, you get -40.5. So feel free to use the calculator to make this easier on yourself. This is not something that you need to bang your head against the wall doing. All right, let's try g of x. So g of -12. Again, feel free to use the calculator. You have -9 I'm just changing my formula. It's -9 times -12 and then minus 108. Okay, so -9 times -12 minus 108, because we have -9 times -12 minus 108. And according to our calculator, it's 0. So is it -3 from before? No. Is it -12 now? No. Let's try -81. So I'm just changing my -12, since I've already put in the formula, to -81. And I get positive 621. And last but not least, g of -7.5 is equal to, this had better be the right answer or we did something wrong. There it is, -40.5. So this is our right answer. All these other ones had different outputs. Not the same, not the same, not the same. So this is the correct answer. So we go back and we say, okay, -7.5. Let's do one more. We have two different values here. Again, we'll make a table. Input value x. The first function there is f of x is equal to -1/2 x, 6. And now our first function, f of x, which is equal to -1/2 x plus 6. And our other function, which is g of x, is equal to 4 log x plus 6. All right, and we have some values to put in. So we can start with negative 6. F of negative 6 is equal to, let's go ahead and punch this into a calculator. We have negative 1/2 times negative 6 and then plus 6. Okay, so the first one is 9. What other values do we have here? The other values that we have are 6, negative 4, and positive 4. So positive 6, negative 4, and positive 4. So first we did f of negative 6, then we're going to do f of positive 6, then we're going to do f of negative 4, and f of positive 4. Plug them in. We already tried negative 6. How about positive 6? That's 3. How about 4? Is 4. Negative 1/2 of 4 is negative 2, and negative 2 plus 6 is 4. So positive 4, we got 4, and negative 4, 8. So those are our 4 outputs. Now, this one over here, log. Log is a little different. So if you have a log function, you know what? I don't know if Google will do a log function. Let's see if it does it. 4 log x plus 6. I doubt it. Negative 6 plus 6. Yeah, that's not going to come up with an actual calculator. So let's see if it brings up the calculator. We'll do it that way. All right, so 4 times log, and then we have this. And negative 6 plus 6. Negative 6 plus 6. Enter. Negative infinity. So that's undefined because we're taking the log of 0, and that's going to be a problem. Okay? So okay, next. We have 4 times, get rid of this. 4 times log 4 times log. It's 12 because we have 6 plus 6. Hopefully you don't need the calculator to calculate 6 plus 6 for you. And you get 4.31. So we've got g of 6 is approximately 4.31. Goes on from there. It's actually more like 4.32 if you round correctly. All right, next up, 4 times log, and you have negative 4 plus 6, which is 2. You get 1.20. So it better be the next one or we did it wrong. And here we go. We have 4 times log. I keep trying to type it in. 4 times log. And then we have 4 plus 6, which is 10. And there you go, 4. So you might be confused by that if you don't know what log is. What is a log? What's a logarithm? It's fairly simple. If you have a log, it's actually a function of exponents. So for example, let's take what we just did. We had a log of 10. That was the only one that came out to a nice round number. All the rest of them were crazy decimals, right? Well, let's focus on the thing that we did, which was 4 plus 6, which is 10, log of 10. And that ended up being 1, because we did 4 times that, and we got 4. So log 10 is equal to 1. Why? Because when you do log, and there's no number written right next to the G down here, it's an invisible 10. And log base 10 is asking you this number here, which like I said is always 10 unless you see another one written there, 10 to the what power is equal to 10? Well, it's 10 to the first power is equal to 10. So log 10 is 1. So if I wrote log 100 equals x, what I'm saying is 10 to what power is 100? Well, 10 to the second power is 100. So log 100 is equal to 2. And if you plug that into the calculator, it will confirm that for you. All you have to do is say log 10, enter. Oops, excuse me, log 100, pardon me. Let's try it again. Log 100 is what we're doing. Enter, and we get our 2. So that's what it's asking you. 10 to what power is 100? So we go back to these other ones. We had other numbers in here that were not multiples of 10. So we had weird exponents. We had irrational numbers for exponents, and it was crazy. So that's why the first one didn't work, because 10 times what exponent makes 0? There is no exponent that you could plug in that you would multiply 10 by to get 0. Remember, 10 to the power of 0 is simply 1. So you can't plug in an exponent that would make 0, but you can, the higher the number that you plug in for the exponent, the closer it gets to 0 if you make that number negative. So that's why it says negative infinity. Anyway, so the bottom line is use the calculator and plug it in, and you will get to the right answer, which in this case was 4. Okay, so that's pretty much it. If you have trouble plugging stuff into the calculator, just make sure you're being careful. For example, here's a real long function. It says x to the 4th plus 12x cubed plus 37x squared minus 30x minus 200. Don't get overly, don't get more confused than it's asking you. That was a weird statement. Take it one step at a time is what I meant to say. Let's do this one last problem. If I've got two functions and I'm putting my input value of x, and then I've got f of x being equal to a relatively simple equation, x squared plus 2x minus 8. And then I've got g of x being equal to this other one, which is longer. It's x to the 4th plus 12x cubed plus 37x squared minus 30x and minus 200. It barely even fits on my paper. So let's go ahead and plug some numbers in for these, and we'll get what we need. We'll get the information we need. What are the possible input values? Well, look, we've got a whole lot. We've got multiple sets here. So we're going to have to plug in a bunch of stuff. Notice that we have 2 in A, 2 in B, and 2 in D. Not in C. It's only negative 2 in C. So probably 2 is going to be one of the ones we want to test and make sure that it works. Because if it doesn't work, then we automatically know that the answer is C. So let's try f of 2. That's going to be equal to x squared plus 2x minus 8. So I'm going to go ahead and plug that in. Here we go. In the calculator, I've got, and I'll put it in parentheses just so it's clear, 2 in parentheses, right? Squared. So instead of x squared, I'm saying 2 squared. Plus 2 times 2 minus 8. So notice that everywhere I put in parentheses is where there was an x. And instead of the x, I wrote our number that we were putting in, which was 2. So 2 squared plus 2 times 2 minus 8. That's 0, according to our calculator. So I can just keep this tab open, and I can change that 2 to a bunch of other numbers. For example, I could try negative 4 and negative 6 really easily, and I could put those into my table. So let's try negative 4 and negative 6. I'm changing all these 2's in parentheses to the other values. Negative 4. Negative 4. So now, instead of x squared, it's negative 4 squared. And then plus 2 times negative 4 minus 8. And again, what's it come out to be? 0. That's interesting. So again, we're still on f of x, but we tried a different input. We get f of negative 4 is also 0. There was one other one, negative 6, on that first choice. What was negative 6? So again, all we have to do is change this value. Negative 6 is the option. So instead of negative 4 squared, it's negative 6 squared. And instead of 2 times negative 4, it's 2 times negative 6. And we get the answer 16. So f of negative 6 is negative 16. If you want to substitute some other values, even though we haven't even gotten to the second one yet, that's fine. We've already done 2 and negative 4. We tried negative 6 on this. We can try negative 5. Let's try negative 5. Okay, so now we have negative 5 squared plus 2 times negative 5 minus 8, and we get 7. So f of negative 5 is equal to 7. All right, so we've got 4 numbers already for our first function. Let's start plugging in some of these for our second function. I'm going to open a new tab, so a new calculator. I don't want to delete that one yet. Let's try the first one. So again, it's x to the 4th power. So the first thing is something, which in this case 2, to the 4th power. And then plus 12 times 2 to the 3rd power. So again, everywhere there's an x, I'm putting parentheses with the number that our input is inside of those parentheses. After 12x to the 3rd power, it says plus 37x squared, so plus 37 times 2 squared. And then minus 30 times x, so 30 times 2, and then minus 200. And what do we get? We get 0. So it does work out g of x, so g of 2 is 0. So the first one is 2 works. So 2 is a value. So when we're looking at our choices, it definitely is A, B, or D. It's not going to be C because it does not have 2 as a value. 2 came out to be 0 for both functions. Let's try negative 4. That was the next one we tried. So g of negative 4. Again, all I have to do is go back to the equation I plugged in already and change all my input values, which again I put in parentheses, from 2 to negative 4 now. So negative 4 to the 4th power plus 12 times negative 4 to the 3rd power plus 37 times negative 4 to the 2nd power minus 30 times negative 4. And look at that, we got 0 as well. So far, 2 and negative 4 both work. So let's go back to our choices, and we can use process of elimination. Well, A, B, and D both have 2 and negative 4. So really, checking negative 4 wasn't even necessary because that eliminated absolutely nothing for us. If we were smart, we would have skipped over negative 4 and went straight to negative 6 or negative 5. We already knew the answer was A, B, or D, and checking negative 4 did nothing for us because all 3 of those answers have negative 4 in them. Now let's try, say, negative 6. Negative 6, that would be equal to, I'll go change all my input of negative 4 to negative 6. And we get 16. Is that the same thing as we had before? No, this was negative 16. Now maybe we want to go back and double check and make sure that we put it in right, but these are different values. They're opposites. Let's try g of negative 5. So again, I'm just changing my negative 6s now to negative 5s. I get 0 again. So those are different. So according to this, we're going to choose D because none of the other ones matched up besides 2 and negative 4. Now, maybe you want to double check f of negative 6 to make sure that you did it right. Make sure that you have it all typed in correctly. Over here, we have negative 6 squared plus 2 times negative 6 minus 8. Oh, and look at that. We did have it marked wrong. It is positive 16. So maybe you saw that in the very beginning. I wrote down negative 16 for some reason. It does say 16. So this is why you double check those things. And be more careful than I was. All right, so we are going with this one because all 3 of those, negative 6, negative 4, and negative 2 did work. There you go. So again, pretty simple. Go ahead and use your calculator. If you have any problem with any future ones, please let me know, and I'll try and help you out with them.